Okay, so last time we looked at the p-value method. This time we're going to look at the traditional method. So we're going to use the level of significance, which is just alpha, to find the critical value. Then we have two choices. So if the test statistic falls within the critical region, we'll reject h sub 0. If it falls outside the critical region, we will fail to reject h sub 0. Okay? Assume that the significance level is alpha is 0.01. Use the given information to find the critical value or values. The test statistic of z is equal to 1.46 is obtained when testing the claim that p is greater than 0.9. Okay, so first is claim, which is p is greater than 0.9. The opposite, p is less than or equal to 0.9. h sub 0 is p is less than or equal to 0.9. h sub 1 is p is greater than 0.9, which between these two, in this case, the claim is h sub 1. Okay, then we're going to state alpha, 0.01, calculate our test statistic. Well, they just gave that to us, 1.46. Step 6 is use the p-value method or the traditional method. Anytime you see the words find the critical value or values, that's going to be using the traditional method. Okay, so I need to find my critical region. And it says that we're going to use alpha to do so. So I need to figure out, do I have a two-tail, a left tail, or a right tail test? And remember, h sub 1 is the one that will determine what type of tail test that you will have. Okay, so h sub 1 is greater than, so we have a right tail test. Okay, and that will be our test statistic, 1.46. Now we're going to use alpha to find our critical region. Okay, so alpha is always in two tails. If you go back and look at these, here's alpha in two tails right here. So if I add alpha over 2 plus alpha over 2, that gives me just one alpha. Okay, so half of alpha is over here, the other half is over here. Whereas if I'm in a left or a right tail test, all the area of alpha is to one side or another. Okay. What we're going to be using to find our critical region is this table right here. Now notice that the alpha level is always in two tails. So this table right here, whenever it talks about alpha, it's talking about alpha in two tails. Whereas since we are looking at a right tail test, this is just one tail. So what I need to do is take this alpha right here and multiply it by 2 and then go to my table. So I'm going to take alpha times 2, which is 0.01, multiply that times 2, so 0.02. Okay, this is alpha in two tails, whereas this one right here was alpha in one tail. Okay, so I need to go back to the chart and find an alpha of 0.02, which is right here. So that's going to give me a critical value of 2.33. Okay, so 2.33, that would be about, we'll say here. And since I'm working with just a one-tailed test, I will have one critical value. Okay, so one-tailed test is the same thing as having one critical value. In this case, it's 2.33, which that was the only thing that they were looking for. But we're going to go on to steps 7 and 8, so you see the whole process. Okay, so if this is my critical value, so this is z is equal to 2.33, which is our critical value, and z is equal to 1.46, that is our test statistic. The critical region is going to be beyond your critical value. So that's going to be this part over here. This right here is my critical region. Now to figure out if we reject or we fail to reject h sub 0, we'll go back. Okay, if the test statistic falls within the critical region, okay, it didn't. If the test statistic is outside the critical region, fail to reject h sub 0. Okay? Alright, so here is our test statistic, right here. And over here is our critical region. Because our test statistic is outside our critical region here, we will fail to reject h sub 0. So let me get rid of this. So we will fail to reject h sub 0. Part 8 is we're going to put everything back into English. So we just found out, okay, we're going to fail to reject h sub 0, which basically means we're going to keep it. Which means up here, we are keeping h sub 0, but we are rejecting h sub 1, which h sub 1 was the claim, so we're really rejecting the claim. Or what you could do is, okay, fail to reject h sub 0, the claim is h sub 1. We can go back to this right here. Okay, we are failing to reject h sub 0. The claim is h sub 1. Okay, so we are going to use this right here. There is not sufficient evidence to support the claim, and then whatever the claim is. Okay, so there is not sufficient evidence to support the claim that P is greater than 0.9. Okay, so that's using the traditional method if we're looking at a right-tailed test. Okay, assume that the significance level is alpha is 0.1. Use the given information to find the critical value or values. The test statistic of z is equal to negative 1.23 is obtained when testing a claim that p is less than 0.2. Okay, so our claim is p is less than 0.2. The opposite is p is greater than or equal to 0.2. h sub 0 is p is greater than or equal to 0.2. h sub 1 is p is less than 0.2. The claim here is with h sub 1. Okay, alpha is 0.1. Our test statistic is negative 1.23. They asked us to find critical values or value or values, so it could be 1 or 2. So that's talking about the traditional method. Okay, so I need to know if I have a left tail, right tail, or two-tail test. So I'm going to look at H sub 1. Because it's a less than, that's going to be a left-tailed. So this is my test statistic. So Z is equal to negative 1.23. Okay. Because I'm in a one tail, this alpha is in a one tail. The area for alpha is in one tail, just like it is for this right here, a left tail test. All the area for alpha is in one tail. But the chart that we use, this right here, alpha is always in two tails, not one tail. So what we need to do is go back to our alpha, and we need to multiply it by 2. So alpha times 2, that would be 0.1 times 2, or 0.2. Okay, so this alpha is in two tails. This alpha right here, this alpha is in one tail. Okay, so I need to look at this number and go back to my chart. All right, so 0.2, it's right there, and that's going to give me a critical value of 1.28. But notice this is really a z-score. So if we go back, the critical value is not actually 1.28. Since we're in a left-tailed test, we need to use the negative version of that score. So we need to use negative 1.28, which would fall about here, negative 1.28 for our z-score. So when you're in a left-tailed test, all your critical values are going to be negative. If you are in a right-tailed test, all your critical values or your z-scores will be positive. Okay, so this is our critical value, which is the answer that they are looking for this question. You could stop right there for this question. But like I said, we're going to go on to 7 and 8. Okay, so right here, the area beyond the critical value, that is your critical region. So here's our critical region. Now you're going to compare and see if this test statistic is inside the critical region, which it's not. Okay, so since it's not, I usually call this critical region the danger zone. So we can make it red. Okay, so if your test statistic is in the danger zone, then we would reject H sub 0 because it's in the danger zone. But since your test statistic is outside the danger zone, it's okay, we can keep it. So we can say fail to reject H sub 0. Okay, so since I've got fail to reject H sub 0, I'm keeping it. The claim is H sub 1, so what I'm saying is I'm keeping H sub 0, but I'm rejecting H sub 1, which means I'm rejecting the claim. Then we say there is not sufficient evidence to support the claim that P is less than 0.2. And that's it.